So when we left last time, we talked a lot about angles and stuff like that on the circle. So let's take a look at some of these things and make sure we've got them down. So let's say we have a circle here with a radius of 8 inches. And we have an interior angle here of 60 degrees. I want to know, first of all, what that arc length is. The arc length. I'm going to give you guys a second to try that on your own, and then we're going to go over it. So what do we do first? Find the circumference, which is going to be pi times 16, otherwise known as 50.24 approximately inches. If you use the pi button, it probably comes up to 50.26. If you did 3.14, it's 50.24. On a tester quiz, I'll have both answers down. So anyway, that's not our answer we're looking for. Anyway, to find the arc length, what do we need to do? So 52.24 times our central angle of 60 divided by 360, which is going to give us 8.37 about. Correct? Questions, comments, complaints? Next. I want you to find the sector area. Okay, so what's the first step? Find the area of the whole circle, which is going to be pi times 8 squared, otherwise known as about 201.06 inches squared. And then, of course, we find the area of the sector, which is 201.06 inches squared times 60 over 360, which is going to give us 37.02 approximately. No. 33, let me redo that. 33.51, correct? Okay. Find that missing length. How do we find it? 2 times 12 equals 3 times x. Okay, so 2 times 12 is 24 equals 3x, and we divide by 3. X equals 8. Very good. If you recall, of course, if we had an angle that had its vertex at the center of the circle, of course, is called a central angle. That's a 110 degree angle. This arc out here is said to be a 110 degree arc. The actual length of that arc depends on the radius of the circle, but a 110 degree arc means it's 110 3/60ths of the whole circumference of the circle. So off of that 110 degree arc, if I have an angle like this, that's its vertex right there, what's this angle going to be? Recall? Nope. It's going to be half, 55. Very good. So let's say I have an arc here that is 80 degrees. What's that angle there going to be? 40. Now let's say this is a tangent here. What's this angle going to be? 40. Even though the one side's a tangent, the vertex of the angle is still on the circle. That was what we called an inscribed angle. If the vertex of the angle is still on the circle, It is half of that intercepted arc, or that arc that it cuts out. It gets trickier, however, when we have situations like this. Can I find that angle based on the arcs? Well, let's try. Let's say that this arc over here is 55 degrees. And this arc over here is 25 degrees. Now, of course, if these intersected at the center, the two arcs would be the same, wouldn't they? So if they went through the center, whatever this arc is and whatever this arc is would have to be the same. As I move away from the center, one arc gets smaller and the other arc gets bigger. The total of the two arcs, however, still stays the same. So all that tells us is if we take these two arc lengths and add them together, so 25 plus 55, and then divide by 2, average them out, we will get that angle. So 25 plus 55 is 80 degrees, divided by 2 is 40. So this is a 40-degree angle here. Find this angle here for me. Okay, so 28 plus 64 divided by 2. What's 28 plus 64? 92 divided by 2 is 46 degrees. Well, let's test out your algebra skills. Find that arc, X, over there. Find the degrees of the arc, not the length, just the degrees. Perfect. Let's take a look. So this is going to be 37 plus X divided by 2 equals 41. You have to multiply by 2 first. So 37 plus X equals 82. Subtract 37. And yes, X equals 45 degrees. Perfect. They're confused, Colt. You had to multiply by 2 right away. Get rid of it. Yep. So that makes this 82 instead of 41. Then you subtract 37. So let's look at this. Looking at this angle out here. If it looked like this, we know that this angle here would be half of whatever this arc was over here. Let's say that this is a 68-degree arc. This angle would be 34, right? Would this angle out here be bigger or smaller? Should be smaller, right? We're stretching it further back. So to find that angle out there, the further we get outside of the circle, the smaller that angle gets. The way we measure how far we've gone outside the circle is we look at this arc here. Let's say that this arc here is 22 degrees. This angle out here is found as the difference between the two arcs divided by 2. So 68 minus 22 divided by 2. Well, 68 minus 22 is 46 divided by 2 is 23 degrees. So this angle out here is only 23 degrees. So let's see. Yep. No, you're just dividing by 2 once. You're going to subtract and then divide by 2. Up here you added and divided by 2 because it was inside the circle. Here it's outside the circle, so you subtract and divide by 2. So 68 minus 22, and then divide by 2. So, if this out here is a 158 degree arc, and this in here is an 86 degree arc, find this angle here. Little hint, if you're using your calculators for these, make sure you hit equals before you divide. So this is going to be 158 minus 86, and then divided by 2, which will give us, 72 over 2 is 36 degrees. So, of course, let's say that this is 146 degrees. And let's say that we know that this is 49 degrees. Find the arc X here. So we've got this one minus this one divided by 2, right? 146 minus X divided by 2 has to equal 49. First step is going to multiply by 2. So 146 minus X equals 98. And then we got to solve this. We're going to subtract 146. Negative X equals a negative 48. And then you're going to divide by negative 1 or multiply by negative 1. X equals 48.
How does that work?
Not always. If this arc over here is big enough, this could be a lot smaller than that. Yeah. Let's test your problem-solving skills. I want you to find this angle out here. If I tell you that this angle here is 32 degrees, and this arc out here is 68 degrees. Oops, can't be 68, sorry. 58 degrees, I should say. Find this angle here, X. So where do we start? Well, first thing we need to do is find this arc over here, and we do that by what? Let's call that Y or something. Y plus 58 divided by 2 equals 32. Then what? Times 2. Y plus 58 equals 64. And then subtract 58, Y equals 6. This is a 6-degree arc here. Then what? Well, we can find X because it'll be 58 minus 6 divided by 2. Oops, 58 minus 6, which is 52 divided by 2, or 26 degrees. How many of you had that? Okay. You'd seen how to do it, though? Okay. That one's kind of a tricky one. Lots of fun. Okay, well, so far all we've talked about is measuring angles in degrees. There's another type of angle measurement out there called radians. In radians, one complete circle is 2 pi radians. What's that? Well, in degrees, one complete circle is how many degrees? 360 degrees. So what that tells us is that 2 pi radians is equal to 360 degrees. So what if I asked you to convert 60 degrees to radians? Well, this is where that measurement conversion that we used to do, or that we talked about a little bit, comes into play. I got 60 degrees. I'm going to make it 60 degrees over 1. I'm not going to put equals. I'm going to multiply. We're going to put degrees on bottom so that they cross cancel out. Radians are going to go on top. 360 degrees equals 2 pi radians. Now, actually, what's probably simpler is you could probably do 180 degrees equals pi radians, right? Cancel out the 2 and the 360. So what we have here, if we multiply this out, 60 times pi is 60 pi. 1 times 180 is 180. This is radians now. Now, of course, 60 and 180 both can be divided by 60 to give us 1 pi over 3. They can be divided by 10, give you 6 pi over 18, then divide by 3. That works. So what if I ask you to convert 30 degrees into radians? I'll have you try that for me quick. So when we look at this, we're going to use this pi radians equals 180 degrees to save us a little bit of reducing. The degrees, of course, cancel out. 30 and 180 could actually cross cancel to give us 1 and 6. So now 1 times pi radians is pi radians. 1 times 6 is 6. So just pi over 6 radians. We tend to leave it in that notation. You could divide it out to get 0.502 or whatever it comes out to be. But we usually leave it as pi over 6 radians. Now going the other way, we might have something like 2/3 pi radians. Or a lot of times we have 2/3 pi, we write it like this. It's 2 pi over 3. Just because it's easier to work with then. And if I want to convert that into degrees, I'll put radians on bottom now. Pi radians go on bottom, 180 degrees on top. So what happens here is the radians cancel and the pi's cancel out. Now you got 3 and 180 can cross cancel. This can be 1 and 60. 2 times 60 is, that'd be degrees. Yeah. 2 times 60 degrees is 120 degrees. 1 times 1 is 1, so that's just 120 degrees. Does that make sense? Kind of. You want to see another example quick before I have you try one? You good? We'll do one more. So let's say I got 3/4 pi radians. Again, we're going to write it as 3 pi over 4. The radians are going to go on top as well. And we're going to multiply it by pi radians on bottom, 180 degrees on top. Radians cancel, pi's cancel. 4 and 180 can cross cancel to give me 1 and 45. 3 times 45 is 135 degrees. Make sense? So I want you to find pi over 8 radians converted in degrees for me. So if we look at this, we set it up 180 degrees over pi radians. So the pi and the radians cross cancel out. 8 and 180 can divide out to give us 1 and 22.5. So yes, it does come out to be 22.5 degrees. Okay. Tomorrow there is going to be a quiz on some of this stuff. Then tomorrow we're going to finish up this unit, which means Wednesday is going to be a unit test. So for right now, you're going to have homework on page 550 through 552. Exercise 25-13, 1 through 11. And on page 557 through 560. Exercise 25-17, 1 through 12.